Bismillahirrahmanirrahim. Dear viewers, today we will start modeling of RCC building in Cypecad 2020. We will model this building, ground floor, first, second and third floor, and this is roof or terrace floor plan. This one is stair top slab. We have prepared plinth beam layout for ground floor, and this is for typical floor, first, second and third floor. With this beam layout, we will model our floor plans in Cypecad. So let's start. First we will open the program. We will go to Cypecad. Click on new project. We can choose our folder location from browse option. Description. Click on accept. Import of BI models. If we have architectural model, then we can import that model. This time we don't have architectural model or other BIM model, so we will start from the scratch. So click on no. Here there are some different option to start new project. We will start with empty project. Accept. Here we will choose our code. Here I will start with IS code, IS 456 2000 Indian code. We can go for ACI code also from here. As we are going for RCC building, so steel, rolled steel, these things we are not going to change. Concrete, this grade we can change from here. I will use M25 for all the members, and here rebar strength 415 MPa. If we want to consider wind loading, we have to click on this. Then from here we can select India. From here we can provide the data as per the location of the building. Here basic wind speed, we can choose the location by city. Here we can get all the city in the list. If we select the city, then accordingly the basic wind speed will be selected. Terrain category, single, 1, 2, 3 or 4. Here we will get the description. Open terrain with well scattered obstructions having heights generally between 1.5 to 10 meter. For real project you have to choose as per the terrain condition. Importance category for the cyclonic region. Here I will choose category 2. Land orography, flat, ascending, descending, hill. Here all the options are available as per the code. I will go with the flat land. Service period 50 years. Here we have to provide tributary width along y direction and x direction. We can measure from the drawing. (12.9 meter). X direction 11.2 meter and X 11.2 meter. Click on accept. Seismic loading, accordingly we can choose Indian 2016. Here we can go for dynamic modal spectral or static equivalent lateral force. In this tutorial I will go with static method. If live load is more than 3 kN per meter square, then we can take 0.5, that means 50%. up to 3 kilonewton per meter square, we can take 25%. So here snow load we don't have, we can leave this one. Estimation of fundamental period of the structure based on the code. Type of structure, here we can provide the height of building, otherwise it will consider from the model. Type 2 seismic zone, according to the region we can choose seismic zone. For example 4, soil type medium soil, effect of vertical seismic component. Here if we want to consider the vertical seismic effect, we can click on this, and here we can provide the modification coefficient as per the code. Here I will not consider this one, so click on accept. Some options for limit states to check the serviceability. I will go with the default one. If we want to change the background color, we can change from here like this black, this white. Now we will define our story labels, then we will import DWG file for our modeling. So go to introduction, floors or groups, new. Here grouped means typical floor. If there is any typical floor, we can click on this and then we can continue. First we will go with single floor, except here we will write PB plinth beam, this one height from foundation 2.2 meter, live load here 0, because in plinth beam level there will be no slab. Except here you can see the floor level, and we can provide the foundation depth 1.6 meter and plinth beam above the existing ground 60 centimeter. Except now go for new floors above this plinth beam, so we will click on above. This time we will go for typical floor for first, second and third floor, grouped. Except here number of floors will be 3. Here we can write 1F, 2F and 3F. Live load 3F. Now here we can provide the floor height 3.5 meter, 3.5 meter, 3.5 meter. Here it is ton per meter square, 0.2 ton per meter square, that means 2 kilonewton per meter square. Dead load as floor finish we can take same 2 kilonewton per meter square. Click on accept. Add another floor for roof above this typical floors. Click on above. This one will be single. Accept. Number of floor 1. Here we will type here roof. Height 3.5 meter. Live load roof live we will take 1.5. Here it is showing ton per meter square. We can change our units. Cancel. From here units, international system IS. Click on accept. Now we can add new floor single accept. Here we can write roof height 3.5 meter. Now you can see kilonewton per meter square 1.5. Dead load in roof. We will provide waterproofing with extra floor finishing. So we will provide 3.5 kilonewton per meter square in roof. Click on accept. If we want to check loading for other floors, we can go to project, general data. Here dead and live load. Here we can check in ton per meter square. We have provided 0.2. 1 ton per meter square is less than 10 kilonewton per meter square. That's why it has been converted as less than 2. So we will provide 2. Okay, click on accept. Add floor. Click on above, single. Here STTOP, stair top. Height, here we can provide 2.8 meter. For water tank stair top slab will have high value of live loading. For example, I am taking 7 kilonewton per meter square. Dead load same as it is, 3.5 kilonewton per meter square. Click on accept. Click on OK. This is done. Dead load, live load. Here you can see. Click on accept. Here we can see one information, that is horizontal or wind or seismic forces should be introduced if the P delta effects due to horizontal loads need to be considered. So we have to consider the P delta effect. Here go to this option. Here it is selected without second order effect. We have to consider this so that it will show with second order effects. Click on this, accept with second order effect. That means P delta effect. Accept. We will go to edit template, add residential building drawing, open. Click on accept. This is the drawing, and here we can filter the layers. Now from here, this option, we can customize our scaling. As our drawing is in centimeter and our Cype model, here it will be in meter, so the scale factor will be 1 by 100. 100 centimeter equal to 1 meter, so 1 by 100, that means 0.01 will be the scale factor. 0.01. Okay, and here we can choose the drawing area which will be shown in our window like this. Click on accept. So this is our drawing template. Now first we will define our columns. So first we will go to column share all. Here new column, reference C1. Here initial group, that means initial level, final level, stair top. Width 25 centimeter and X width 25 centimeter, Y width for example 50 centimeter. From here we can change our shape. If it is circular, we can go for circular. If it is composite, we can go for composite. It is as it is rectangular concrete, so we will select this one. We can go for section designer also, like generic section. We can add. Here we can draw the L shape or different shape. Then we can import. Click on accept. 25 by 50. Click on accept. Here we can turn on our snapping option from here. Activate. Accept. This one, this direction. So we will start from here. Now for internal columns, we can increase our section 25 by 60. Click on accept. For column rotation, we can go for right click, then angle 90, accept. So our column modeling finished. We can edit columns. This one we can change the dimension 50. This one also 50. Click on accept. Now we can adjust our columns. We can edit this one. Now it is okay. Go to adjust. Move this one to this point, then go to adjust like this. Four columns will be up to stair top, so other columns we will edit. This up to roof, accept. Now go to new column, up to roof, 25 by 25, accept. So this done. So our column modeling finished. We can check in 3D view from here, beam definition, 3D view. This is our columns, only 4 columns up to stair top. Okay, now we will define our beams. Go to beams, define beam. Here type of, here the family, flat beam, this dropped beam, this lattice beam, this beams with external fixity, this pre-stressed beam, this foundation beam, this non-structural or limit beam, steel beams, timber beams, and here are the different types. By 50 cm. Click on accept. Here we can change the modeling adjustment. If it is center, it will draw like this. If it is left, then it will be like this. Now we can go for extend beam. Like this. And for smaller beams, 25 cm by 40 cm, we'll go for this. So all the beam finished. Now we will delete our extra portions. Now here this what symbol is asking for slab definition. Go for panel manager, define panel, flat slab on beams 18 cm, except this is plinth beam level, so here I can just draw the slab and later on we will delete to create opening, otherwise it will show the warning that in plinth beam level there is no slab definition. So now delete panel, that means enter opening. Okay, plinth beam level done. Now we can go for upper floors. From this arrow, upper arrow, we can select from here also these floors. We can edit our group name also, edit groups. Here 1 2 3, typical 1 2 3, accept. Now go to beam definition. Here we are in typical 1 2 3 floor. Now what we will do in this single floor, that will be done in all the typical 3 floors. According to this beam layout, we have done our plinth beams. For floor levels, we have to follow these beams. Here this is hidden beams. These hidden beams are provided because we don't want to see the beam dropped inside the room where there is no wall. Here we can copy beams from plinth beam level also. Then we will keep similar beams here, and other beams we will delete. Go to group, copy from another group, select this plinth beam. What we have in plinth beam, that is copied to this typical floor. We can see in 3D view. Here you can see plinth beams added to typical 3 floors. Now here we will delete our beams which are not matching with these floor plans. So delete this one, delete this one, and we can go for new beam 50 cm by 38 cm as inverted beam. because for sunken slab will be at bottom of the beam depth. Activate orthogonal option like this. We will delete the extra portion, this one. Now another beam, this one will be 60 by 38. Click on accept like this. Then extend beam, this one, extend, delete this one, delete this one. So we can delete this beam, then go to define 60 by 38, then extend like this, then delete. Go to analyze. From here we can check our geometry of all group. Here the meetings of beams at the coordinates 4.27 and 3.6 are incorrect due to the meeting of beams at different heights without overlapping. So here we can check where is that location. Go to beam, define beam. Here if we press number 8, then it will give the option for locating the coordinate. Here we can write 4.27 at it was 4.27 as it was showing in the message 27, and y coordinate 3.6. Press enter. So this is the ordinate, here is the problem. To find out the ordinate where is the warning or error showing, we can go with this process. So now close this one, right click, inverted, and this one dropped. We can check in 3D view. See, this is in different level, that's why it is showing the warning. This one we can define this beam as below. We can edit this level later on, we will see. Now we can go for slab options. We can go to panel manager, define panel, same 18 centimeter. We will go for same thickness for all the floors. Here we will provide stair. We can see the 3D view like this. Where there is hidden beam, there we will provide sunken slab. That means slab will be little bit down from the floor level. So how we can provide that one, we will see now. Close this one, go to group, sloped floor. Here we will add a different level. We can write here 20 centimeter down minus 0.2 meter accept. Now assign the floors, this floor related to hidden beam. Okay, now we can see in 3D view. Here now we can see this hidden beam is matched with this beam top, but other beams went down with the slab. So if we want to bring this beam to its original position matching with this hidden beam top, so what we can do, go to floor level, group. Here we can original position, assign this beam. So now we can see the 3D view. Here we can see this is the hidden beam and this is sunken slab. Now we will go for roof floor. Go to next floor. Here we can copy all the things from typical floor. Here our live load and dead load is different, that's why we have defined this floor as single, not in typical group. We can go to group, copy from another group, okay, like this. So everything copied from typical floors. We can go to stair top level. Done. Now we can check our model, check the geometry of all groups. See here, now there is no warning. We will add our circular beam now. Here typical floor, go to beam, this one, except this center, this curved, center of column, here center of column, close this one. Now here we can define slab like this. Go to roof, now we can see in 3D view like this. So this is our model. Check our geometry, there is no error or warning. In the next tutorial I will show applying wall load as line load and modeling of stair. So thanks for watching. Stay tuned for more upcoming important tutorials.
Press the bell icon on the YouTube app and never miss another update.